All right, we are going to be going over in this video the first derivative implications section. So when we are looking at the implications of a first derivative, we know that first derivatives give us information on relative minimums and maximums that can also be absolute mins and maxes, right? But when I am going through this, all these answer choices are talking about critical or absolute. So I wrote my little note here that we do need to check the first derivative. If the first derivative equals 0 and is changing from positive to negative, right? So we're changing from increasing to decreasing. That gives us a max. From decreasing to increasing gives us a min. It is really important to note, though, that we also have to check, because these word choices are absolute, we would also need to check these endpoints. So like our key here is we are checking endpoints and where f prime of x equals 0 and changes. So let's get that done. My check table, here's my x, here's my f of x. We're going to check -1, and we are going to be checking 3, and I will get those other values as I go. F prime of x, we're just derivating that. When I set that equal to 0, I get that x equals 5/3. So that is going to be, and I know that we're actually going to be crossing the axis at 5/3 because if I think about this equation, it is linear, it has a y-intercept of -10 and a positive slope. So we are going from negative to positive. So this indeed is a minimum. I just don't know if it's going to be an absolute minimum, or if it's like lower at one of the endpoints. I'm going to be plugging all these values into my original function. So the first value I'd be plugging in is positive or -1. When I plug in -1, I get 20. I mean, honestly, at this point, we can choose the answer of D. But if you were to keep on going and fill out these other pieces right here, let me pull up that key. You could have seen that -1 or 5/3 gives you 1 point, -1, -4/3, and then 3 gives you an output of +4. So I'm going to come back out here, -4/3, +4. So here is going to be my maximum. Next guy right here, we are just actually looking at key features here, like identifying the difference between those mins and maxes in this scenario. So relative minimums, this does not give me any information about this being a derivative, so we're just going to assume that this is the original function. So relative minimums would just be where that function dips. This is going to be the minimum is at, we can say at x equals e and I, or f of x equals tx, because those would be those y values. The maximums are going to be where x is g and c, or f of x equals vr. The absolute, so that's talking about absolute lowest that we're going. The lowest value is going to be this point AP. So is f of x equals p at x equals a. The absolute maximum value, the highest my function goes, is this point CR. So f of, I'm just going to say f of c equals r. The function is increasing, so remember we're looking for all of our increasing intervals. Just going to highlight all of these guys. And then conversely, I'll just get all those decreasing intervals as well. So we are increasing. We always use x intervals for increasing, so we're increasing from A to C, union E to G, union I to K. We are decreasing from C to E, union, should just be these middle guys, G to I, because this is a continuous function. If f of x equals x minus 2 cubed plus x plus 1 to the fourth, then which of the following is true? We know that increasing and decreasing intervals, this is going to be increasing when f prime of x is greater than 0, right? If that derivative is positive, my original function is increasing. And we know that we are decreasing when f prime of x is less than 0. So let's get that derivative and figure that out. We are going to be using product rule on this guy right here unless you wanted to FOIL that all out. I highly do not recommend that. That's why we have product rule. We're going to do the derivative of the first times the second. So 3 times x minus 2 squared. Chain rule, but the derivative of x is just 1. Don't touch that second equation. So that's x plus 1 to the fourth. Plus, we're leaving the first one now, and then the derivative of the second. So 4 times x plus 1 cubed. Now, since we're looking for like those benchmarks of 0, I really need to get this into some sort of a factored form of a polynomial. To do that, what I'm going to do is I'm going to pull out GCFs so that I am left with hopefully 3 factors in the end. It looks like the most x minus 2's we have are 2. So I'm going to pull out 2 x minus 2's. And then I'm also going to pull out 3 x plus 1's. When I factor that out, in my first term, I'm left with 3. All the x minus 2's are gone. I'm left with 1 x plus 1. Because there were 4, I pulled 3 of them out. In my second term, I am left with 1 x minus 2, and I took away all my x plus 1's. When I simplify this, I am left with what? 3x plus 3 plus 4x minus 8, 7x minus 5. This is that f prime of x. So I can find my zeros here. My zeros are going to be positive 2, negative 1, and 5/7. So to get a good idea of my intervals of increasing and decreasing, I'm going to plot these all and make a sign chart so that I can use that to determine what's happening with the original function. For my sign chart here, let's get these all laid out. Negative 1, I'm going to order them 5/7, 2. And you can plug in some values and use values that are in between. I'm going to use like the end behavior of that derivative graph to get that figured out. I know that this is going to be 1, 2, 3, 4, 5, 6. So this is going to be an even function. It's positive. So my end behavior is up, up. We are crossing at both. We are crossing through, and then we're going to bounce at positive 2. So what that would look like, we are crossing through negative 1. So your function would cross through, and then bounce. Go back to those beautiful graphing, algebra 2, and pre-cal skills. Because my derivative is above the x-axis, it's going from positive to negative to positive. So it looks like my function is increasing over 2 intervals, right? So from negative infinity to negative 1, it's increasing. And then from 5/7 to infinity, it's also increasing because it's above the x-axis. And then from negative 1 to 5/7, we are decreasing. The only correct answer that meets what we determined is going to be C. Final one, we have a table. The derivative f prime of a function is continuous and has exactly 2 zeros. Okay, this is important information because when I'm looking at derivatives, you cannot assume unless told that this is a continuous and not a discrete function. Additionally, a lot of times, if that is not given information, you have no idea. Even though it's negative at two numbers, we have no idea if it jumps up in between. So it's like, just my whole point here is like, don't assume what's happening with this function unless you're told, or like there might be a discontinuity, I guess is where I was going. So if the domain, oh, exactly 2 zeros. There we go. That's good information as well. That means that it's not going to be crossing the x-axis more than we see. Select the values of f prime of x where it's decreasing on the following intervals. So here's our 2 zeros. This is important to note. Because these are our only times it crosses the x-axis, since this says it's negative between these numbers, that is true. This function remains negative. So it doesn't do that little thing I just showed where it could potentially like jump up between two values. What this is looking like, right, if I get a little visualization, is that we have a 0, -2, a 0 at 3. It looks like we are positive slopes, negative, and then positive again, which means that we are decreasing in this interval. So right here, I'm going to say f of x is decreasing from, let's call -2 to 3. Because our slope is 0 at -2 and 3, we're going to use parentheses here and not brackets. And we are going to say because f prime of x is less than 0 over that interval. And you are done.